Yeah, we're live. It is 1:58 here in sunny-ish California. Today we're going to talk about the video I just posted up, just loaded it up just now. So if you haven't, go take a look at it. But it is I think what is probably going to be the final test or video that I did on the 4.8 liter so far with the M90 Supercharger, because we ran a bunch of tests on it. The cool thing is that I ran a bunch of direct back-to-back tests on this. So it would have been easier just to put all the stuff on it and go, hey, look, we made all this power. Certainly would have taken a lot less time, not several days of actual swapping things over. But what I did was we ran back-to-back tests comparing the 706 to the 799 heads by themselves. Then we ran two different camshafts. We ran the Brian Tooley Racing Truck Norris cam versus the Hot Rod cam. So which one of those do you think is a better blower cam? Then we ran, so we ran 1 3/4 versus 1 7/8 headers, the two camshafts, and then the 799 versus the 706 head. So cylinder heads, camshaft, and long tube headers. We also ran the radius entry, but as I've talked about a couple of times on these live feeds, the radius entry going into the throttle body looks awesome, and I want it on every test that I run now. I need to get one of those. Although I think that this one was not a 4-inch one, and I would like a 4-inch one. I'd like a 4-inch inside diameter one that they stamp and make into this bell mount, because this looks like a formed piece, a formed aluminum piece. But I'd want a bigger one. But it looked awesome, and I want it on all of my tests because it's cool looking. But it showed no power, not because they don't work or because it doesn't improve airflow, but because we already had limited airflow, on the other side of that, on the inside of that, between the blower and the throttle body was our problem, not the throttle body itself, and definitely not the giant air horn that flows 1 million CFM. So it wasn't that. So that didn't work. And that was one of the things I tested that didn't show power on the little 4.8. Maybe there's onesies or twosies or whatever, just, but not enough to make a big difference. So, but the cool thing is, if you look up at the video, the cylinder head test showed once again that on a small bore LS 4.8 and 5.3, it's actually pretty hard to beat a set of stock 706 heads. There's nothing else that you're going to put on there that's going to make more power than that. No other stock head. We already know from other testing that you can't put a set of Recport heads on there. They flow a ton, but the chambers are gigantic, and the valves are too big, and they're spaced out, and all of that. So it'll hit on the small bore motor, so you can't run those. So it leaves you with all the cathedral port stuff. Well, 799 head has too big of a change in static compression, because even if it flows more, which it does, it never catches up to the smaller head. The 799 head has a smaller chamber than the 317 head, but it has the same kind of problem. It's a couple of cc's bigger than the 706 head. It also, and people never mention this, they always mention it's just compression. It's not just compression. There are other things going on there. The chamber itself is bigger, not just bigger in volume, but bigger in what I call inside diameter. So from side to side, if you measure side to side on that thing, it overhangs the bore size on a 5.3 and a 4.8 on that 3780 bore. It overhangs it. It has bigger valves. The valves are shrouded because it overhangs that. So it doesn't work as well as it should. Even if it flows more, it probably doesn't flow more on that bore size. So, and just, it's not as effective. That head is not as effective as the other head is. And I know GM used them, and I understand all that. But that doesn't mean in the back-to-back test, we didn't get the results that we get. And we get that all the time. And on this test, it was a supercharged combination. So would you think that on a supercharged combination, it'd be more likely that the bigger head, because we're running enough, we're on the camshaft, we're running enough, we would eventually be running enough lift, but we did do the head test with the smaller camshaft. So was that the problem, that we had the 550 lift camshaft oh no, we didn't even have that. We had a 500 lift camshaft. So now we get the real story. I forgot about that. So we did the head test. I put the heads on before we did the camshaft. I'm thinking that it was the other way around, but it couldn't be, because I did the head test before I did the camshaft so that we would have the valve springs on it. So we had a camshaft that was like a 500 lift camshaft. And so we couldn't take advantage of what the 799 heads had to offer. So what do you guys think? I'm sure I'm going to get comments like that now on the video. What do you guys think? In fact, that will be our poll. That's just so good in so many ways. Okay, so would the 799 heads make more power? And the 706 on the Supercharged 4.8 if it already had a bigger cam. So if the motor had the bigger cam in it, a 600 lift cam that could take advantage of where most of the extra airflow is on the 799 head compared to the 706 head, would it make more power on this test if we had have done this head test basically after a camshaft? So if we had enough spring rate in the 706 head, and then and then had that Brian Tooley Racing hot rod cam in there, and then did the head test after the camshaft, would the results have been different, basically? So let me know what you guys think. Let me know what you think. But again, good. And I'm glad that we went over this stuff, because sometimes in my mind it works out differently than it actually does. But good test. The interesting test for me was not that so much, especially now considering that it was a 500 lift cam. But the interesting thing for me is that, and as a side note, because when we ran the 6-liter motor that made like in the 500 horsepower range, the 799 heads did better. I mean, they made more peak power. They didn't make as much power down low, but they made more peak power than the 706 heads. But that also had a bigger bore. So did the Supercharger make it for the bigger bore? It's interesting. Let me know what you guys think. The interesting test for me was actually not that. The interesting test for me was the header test. So we ran 1 3/4 headers with these headers have a collector extension welded onto them. So we ran 1 3/4 headers so that I could run the 802s so that we could get O2 readings and figure out whether or not the blower discharge positioned over the front 4 cylinders was favoring those cylinders. So that was a separate test. That video's up. You guys can check that out. But we ran those headers, and then I wanted to put the other headers on that we had run previously, because we had 1 7/8 swap headers, I think, from the guys at Holley. And then also because they have a V-band flange on them, I always hook up the exhaust to that, and that's a 3-inch section with a V-band on it, and then MagnaFlow straight through 3-inch mufflers on it. I like that because I don't like to listen to, because I'm doing this for hours and hours and hours and hours. I'm wearing ear protection too, but there's just no reason to run unmuffled, motors on, for especially at this level. We're talking about a little 4.8 with a cam in it, and yes, it has an M90 supercharger on it, but those headers or the mufflers are not restrictive in any way for this kind of combination. In fact, as we saw in this test, we ran the 1 3/4 with an open collector and a short extension. I honestly think that more extension would have helped this combination, certainly down low. But running the 1 7/8 headers into with the long collector extension, because that's important, and the muffler made more power. It made more power, and made more power on the top. I think starting from about 4,000 on up. Yeah, from about 4,000 on up, the 1 7/8 headers with the mufflers just made more power than the 1 3/4 did. So what do you guys think? Do you think that, the bigger headers just flow more? Do you think that this was a particularly tuned scavenging thing going on? What do you guys think? Why do you guys think? Let me know in the comments. Why do you guys think that particular set of headers, and again, not chosen for anything other than they were hanging on the rack of infinite headers that we have to choose from? I think we probably have about 6 sets or something, probably more if we consider the stock exhaust manifolds, and then the shorty ones that we have, and maybe some mid-length ones that they have up there too, although I don't typically run those. when I'm doing a test of stock exhaust manifolds versus shorties versus long tubes, then there's that many to choose from. And then there are a number of different long tubes. We have those QTPs or 1.75 V's, which are, I think, are Schoenfeld. They're kind of a sprint car type headers just to make it easy to get to stuff. Quite honestly, I like the ones that are chassis style headers that I run the mufflers on best. But I've always thought that 1 7/8 headers on a mild truck Norris NSR cam 4.8 was probably overkill. But are we getting some good like cross mogenation going on from the high ram runner length and then those 1 7/8 headers, the scavenging from that along with the cam timing? You know, is all that happening? Does the question is, do those headers, do the 1 7/8 headers specifically work best with boost or the high ram runner length and RPM range and camshaft, the hot rod camshaft, or all of those things? Just let me know. We you know, you guys can talk amongst yourselves and figure out what's going on. Closed pole is an option. With the 799, it'd make more power than the 7706 on the Supercharger 4.8 if it already had a bigger cam. So most people are saying yes. Interesting. So we'll scroll back and see. I'm excited that video is up. It's good. I might do a comparison now. Well, we won't talk about that. We'll do another comparison later on. See how everybody's doing. We are live. How about Hooker turbo manifolds? I have tested the Hooker turbo manifolds already. In fact, their turbo kit that has the one exhaust manifold on the passenger side where they merge together and then exit out a single 3-inch with a V-band. And then on the other side is a dedicated turbo manifold with a cross under. I've tested that. But the Hooker, the manifolds themselves, the turbo setup I've done. But are you talking about the other just cast exhaust manifolds that people use? More AMR 500 stuff. I am definitely going to do that. I'm going to put that on a vehicle and or on a motor on the engine dyno. One that will work with that size blower, like a sub 150 horsepower motor. For street application, recommend on headers. What Vincent, what motor do you have? And what's your combination? Is it a truck? Is it a car? What is it? Normally somewhere in the 1 3/4 to 1 7/8, 1 5/8. A lot of times, if it's a milder 5-liter Ford, but if it's an LS, you saw the 1 7/8, 1 3/4. There's usually not a big difference in power between those and the NA stuff that I've tested. But in this particular combination, it's certainly like the bigger headers. But shorty headers will not make power over stock exhaust manifolds. Very rarely do they do that. Long tubes definitely will. Love the 671 496. Would love to pick your brain about cooling that engine. Is it in Evan, is it in a car or is it in a boat? What is it? What about step headers? We have step headers there, and I've run them many times and compared them to standard style headers, non-step headers. And it just isn't a big change. What would be a good throttle body size for Sentra? Stock is around 60, 75 is too big. The only thing that the bigger throttle body is going to get you is some drivability issues. I don't know what kind of power level you're looking for, but anywhere from the 60 to 70 millimeter is fine. A 75 is nice because it's 3 inches. So if you're using a 3-inch tube going from your turbo up to that, it mates on there pretty well with a coupler. It's just that the throttle body gets too big. It gets really super responsive. Less of a problem with a turbo because you'd have to wait for the turbo to spool up, slightly anyways. But on NA things, which can be problematic, and certainly on positive displacement blowers, it can get touchy when you get big throttle openings. Next M90 test, can you leave a 3/8 vacuum port open to see if boost and power loss? So you want it to be 3/8? The tiny cam, the 799s couldn't shine. Hooker, headers, manifolds. The cast iron exhaust manifolds are not really going to be much better. They're basically a shorty header. They're just in cast form. So they're not going to do what long tube headers do. The question is, would 799 I did a 799 versus 706 head test, and the 799 heads didn't do anything. But would they do something? Would the 799 heads make more power if I did that test with a bigger camshaft, basically, is the question. Burns, explain to me how you think that a bigger throttle body would ever lose low end or mid range power. I've never seen that on lots and lots of Honda stuff that I've done, turbocharged stuff. I don't know how the bigger throttle body could ever change the power, since that's not dictated by the throttle size. Do the 799s have smaller chambers? The 799s have stock chambers, and the 706 have stock chambers. The 799 chambers are bigger than the 706 chambers are. Neighbor kids say they make all the power, all of it. I'll tell you. The specs offhand, so I can vote no, but I'll pick one. Okay. Yes, the manifold, the whole kit. The Holley kit for the turbo stuff worked well. I have videos up. You can take a look at that. It's not what I would pick if you're going to try to go race that thing, because there are better flowing things that you can get. But for 800 or 900 horsepower, that kind of thing, it packages well and it fits, and it's cast iron and it should last forever. Dark mode on YouTube doesn't allow you to see questions and polls. I don't even know how to do dark mode, so I wouldn't have engaged that on mine. Turbo sensor, you won't have any problem with a 75 millimeter throttle body. If only I had a garage with a hoist and a lathe and a Bridgeport and a mill and heat. Seriously, you want all of that? I wonder if I could make a lathe. They sell the little lathes at Harbor Freight. I've seen guys work those. 1/2-inch vacuum lines. I sang the documentation in the past showing the bulb. Yeah, I know that. But when I did the test, I only did it with the very small pipe thread. Freiberg showed the head usually doesn't make difference in a boosted motor. Bigger cam should improve power under boost. I'm using dark mode. Okay. I think the 799 heads have more potential at higher horsepower levels. Bigger throttle bodies will hurt low-end power in an EFI. In an EFI application, don't need the bigger throttle body since you're pushing boost through it. Okay. I can tell you in all the testing that I've done, a bigger throttle body has no effect on power. It either has a positive effect or zero effect. If there isn't enough flow, the throttle body helps. If there is enough flow, then it does nothing. The only thing that it does do is makes it really responsive when you tip into the throttle when you're driving it around, because all of a sudden it has like a big amount of airflow. But other than that, it doesn't change the power at all. I phrase that wrong. It can feel weird as if there's a loss. Too many people are too many are to use 0 to 100% throttle instead of rolling into it. And I've people say that car feels lazy afterwards. How and when did Freiberg show the heads don't help on a boosted application? I've run head tests on boosted applications before. I did a big block where we did 315 head AFR heads and then 335 AFR heads, and it made no power NA, and it also made no power under boost. But again, because The 315 heads that we had from Airflow Research were already really, really good and already flowed more. They were either 305s or 315s. I can't remember which ones. I have to go back and look it up. But at any rate, they were more than enough head for the 496 that we were testing things on. And they were more than enough head when we had our 871 blower or whatever we ran on there. So there's no gain NA and no gain under boost because they were already enough. If we would have tested stock heads boosted and then better heads boosted that actually showed a change in power NA, we would also have seen a power under boost. India called you 17 times today. How's the fuel with the cam and blower on the test? What do you mean, how's the fuel? You said that the small port open you lost. I think it was 3 or 4 tenths of a pound. So at 3/8, I wonder if this could be worth a pound of boost. I think that that's possible. Please test tri-Y headers and or speak to your experience with them for a split plane V8, a 215 Buick. I have no experience with a tri-Y header on a V6, and I don't know how you're going to do a tri-Y header on a V6 anyway. Or no, okay, a 215 is a V8. I was for some reason I'm trying to draw all the lines on the V6 header, but on a V8, yeah. I've run V8 or tri-Y headers on small block Fords. I think that that's the only time that I've ever tested them. And a tri-Y header is not an absolute thing in terms of design. So a specific tri-Y header that you would be testing on a specific application versus a specific other kind of header, a shorty header, a stock exhaust manifold, a 4-into-1 conventional header. But how did you do that 4-into-1? Does it have a merge collector? Does it have a collector extension? What size is it? You know, there's an awful lot that goes on to headers rather than people want tri-Ys to be all about torque and they want 4-into-1s to be all about peak horsepower. But that's not the case. It depends on what you're doing, what the lengths are, where the merges are, what the sizes are, all of that stuff. Thinking of an engine like an air pump, I'm guessing getting as close as you can on flow for both the intake and the exhaust would be the most ideal. Is it fed enough for the cam and blower combo? We have the air fuel optimized at the right air fuel ratio for all the combinations. Every combination that I run has the right air fuel and has the right amount of timing. So yes, we have more than enough fuel to feed it. Richard, would leaving out the intake portion of a forced induction setup on the dyno be a good test for calculating or demonstrating parasitic losses? No, it's a terrible way to do that. Just having it blow out to atmosphere on a turbo would do nothing because the turbo has to be a cycle. So you're blowing boost in that's adding more exhaust out. It's creating more boost going in. And so it has to be a cycle. So turbo won't do that. A centrifugal blower will do that because it's just relying on blower speed, but you're not building any boost in the motor. All you're doing is blowing air, and the centrifugal supercharger never does that in the real world. What you have to do is the way that a blower dyno works, and we did this on the little AMR 500, is you have to restrict the boost out of the blower. So you have to have it make boost. So how much boost does it make on your engine combination? And then you have to vary that. You have to park it at some RPM and see how much power it took to make this blower speed with this boost level. For instance, when you run a centrifugal blower, you might be only making a pound or 2 pounds down at low engine speed. So you have to load the motor at 2000 RPM or 2500 RPM, restrict the blower so that it's making 1 pound or 2 pounds, check your power outputs, and check what the difference is between that it took to drive that blower and the NA power output. Then do it again at 3000 with another amount of boost and change the restrictor. You might have to change the restrictor, probably will, so that it's producing the amount of boost that the motor makes, that the blower makes on that motor when you run 3000 RPM with that pulley size, and so on and so on and so on and so on. And so you have to do all of that. That doesn't work with a turbo, but it can work with a centrifugal blower, and it can work with a roots blower. If the roots blower isn't blowing into the motor, you have to remote mount it like we did with that AMR. The best way to do it is actually to put on a blower dyno, which I did with the guys at Kenny Bell. I made my own blower dyno with the AMR blower. You should get Brian Tooley to custom make a blower cam for M90 max effort deal to snare 600 horsepower. Brian doesn't need to make a custom cam for that. Speak to low RPM torque maximizing street application. You need to be more specific about what you're wanting. What motor do you have? What transmission do you have? What gearing do you have? Where are you trying to make power? What RPM range? Because most people don't go to wide open throttle at 2000 RPM. So guys that are trying to make lots of low speed power at 2000 RPM really just need to be in a different gear. So we could talk about all that, but there are ways to make low speed power. One is displacement, another is compression, another is boost, the other is really, really long intake runner lengths. Camshaft, not so much, and I'm talking about like 2000 RPM. Camshaft, not very much. Ported head, not that much. And again, depends on what we're starting with for cylinder head versus what we're ending with for cylinder head. Long tube headers can come into play there, just like really long runner intake manifolds. I can hear the sound of one hand clapping with a big block cylinder head airflow answer. Only just one. The pull isn't working. Richard, I ran into a set of 460 heads, bare aluminum Cobra Jet exhaust, Speedmaster being that they're Cobra Jet exhaust type. I assume that they will be a ripoff of a Ford Super Cobra Jet head, or am I wrong? I don't think that. I mean, you'd have to find out from Speedmaster if the head that they used to make their aluminum head was a Super Cobra Jet head. I doubt that that's the case. I doubt that they ever got their hands on a set of Super Cobra Jet heads, because they're very, very expensive and hard to come by. And if you are going to build and unless you mean a Ford Super Cobra Jet aluminum head from Ford Racing, that would be more likely. It's not good for the blower either. It goes over max speed. Torque maximizing street application means get a diesel. A diesel is better for those kinds of towing very low RPM applications. Poll's working for me. Yeah, it's working for most people. Richard, can the 8.1 block be used on any of the, I'm sure you mean LS stuff? That's a different engine family. It's not interchangeable. The only thing that is interchangeable, coil packs are interchangeable. Firing order, but not the camshaft, just the firing order. And you have to, I think we had to flip the crank sensor wiring, if I remember Amos told me, but we run an LS harness to run the 8.1, but not the other stuff. Injectors you probably could, but not fuel rail, not intake manifold, not cylinder head, not any of that stuff. Yes, from the Ford Racing, not the rare. Yep. What air for a hot side of a 62 millimeter 3-liter? So I don't know what 62 millimeter you're talking about. But if you're looking for 600 wheel horsepower, 62 millimeter would definitely get you there. If you're looking for the most response, then you're looking at the tightest AR. But I don't know what your hot side is. How big is the wheel and stuff on your hot side? How about a test on something like a stock 5.3 with a turbo making 15 pounds vented to atmosphere to see what the drive horsepower is on a turbo? You can't vent a turbo to atmosphere and tell you what the drive horsepower is on a turbo. It doesn't work that way, because you won't have the amount of exhaust flow going through the turbo if you just vent it to atmosphere, because now the turbo motor isn't making 15 pounds worth of power and exhaust coming out of the motor to drive that turbo to have all the back pressure, that's taking away the horsepower. Stock throttle body was electric, is only open to 80% and was slow to open, so I'm sure anything other than stock will be better. Yeah, are you going to a manual throttle body, or are you still going to do a drive-by-wire turbo? Let me know. Anyone swap out intake valves on L92 heads with bigger stage? I was told to go with lighter intake valves. So what are you going to put in? Are you going to put in the LS3 valves? They're better. They're lighter. But it's not really necessary unless, are you trying to run a really high RPM or something? Do you have valve control problems? Recently saw a test with the Garrett G30 and different ARs. Somehow the bigger AR spooled better and made stronger power. I don't know how that's possible. I didn't see the test, but I don't know how that's possible. If everything else is the same and the only thing that they're changing is the AR, I don't know how a bigger AR spools better. I've never seen that. And I've tested lots of AR stuff. And when you do that, it follows exactly what physics should say things should do. If you have a smaller opening and a smaller flow path going through, that it'll spool the turbo faster. It will have higher back pressure, but it will do exactly kind of what you expect. Was told the LS3 is better, just looking for the best combination. Don't look for the best combination. Figure out what you're trying to achieve, and then figure out how you go about achieving it. Don't try to individualize each part and try to get the best of everything. You don't need that. I mean, what kind of power are you trying to make? What kind of RPM are you trying to make? And then we'll help you steer you in the right direction so that you don't have to buy expensive valves, because they're probably not going to be necessary. I heard a guy involved in turbo say that a decent turbo setup can have lower exhaust back pressure than intake pressure. Yeah, my Bonneville motor had less back pressure than boost pressure. That's easily possible depending on how you size the turbo and what power output you have and what your NA combination is. That's easily possible. The problem is that it's not usually very responsive. And for Bonneville, we didn't care. In fact, we wanted the turbo to come on later. What do I need to do to make my 862 heads make power all the way to 8,000 RPM on my 5.3? You need to look at other things besides your heads to make power at 8,000 RPM. But porting them, having properly ported heads that flow 300 or 325 CFM will help you with that. But this is going to be more in the camshaft and intake manifold than the cylinder heads. Plans to get 500 horsepower on L76, then add boost once I get to 500 horsepower. Well, an L76 is just a cam and springs, and you will be making more like 550. So you're good. I want to make sure that I know what I'm talking about here, because there's a chance. 6-liter Gen 4 small block. Holden, Commodore. And there are rec port heads. Yeah, you're just ahead. You're just cam and springs away from making lots of power with that. Ever heard of a Mercruiser 470? Yes. Thinking about using parts from a 97 Mustang. Yeah, just use stuff that's cheap and easy to find and easily replaceable. LS Momo, take a look at like the Summit Pro LS Stage 4 camshaft, or Brian Tooley Racing Hot Rod or Red Hot Cam. All of those will make that much power. And other guys do them, Texas Speed and Cam Motion, and all of the guys, Iski, everybody has camshafts that are going to be that big. They're all going to be in the 220s or 230s at 50. Back pressure is absolutely one of the most important things when choosing a turbine housing. Referring to the exhaust side, that's why I said hot side when I wrote 62 millimeter exducer. There's a 1.5 inch wastegate big enough for 300 wheel horsepower. How big is that? That's not. 38 millimeters? Yeah, that should be big enough. The person that's wanting to run 8,000 RPM, why are you wanting to run 8,000 RPM? And you realize that the number of problems that you're going to have running your 5.3 at 8,000 RPM are going to be like 1,000 times more than running it at 6,500 to 7,000, where you should be running it. Richard, I'm building a track focus project car. I'm putting LS2 in it. The goal is to make 425 to 450 horsepower at the tire. That's certainly possible with a 6-liter. Ported LS2 heads, the 243 heads will do that. A better intake manifold, the LS2 intake manifold is not great. A fast intake manifold, some sort of biggish cam, the hot rod cam or the red hot cam, or a comp 459 or 469 cam, or the Summit Stage 4 cam. And lots of people have other ones too. Texas Speed, everybody has other ones. I just am not as familiar with those because I haven't tested a lot of them by name. But any of those are going to put you at 525 to 550 at the flywheel, which is going to be 450 at the wheels. There's anything you recommend doing internally to the motor for extensive high revs for long periods of time? Yeah, you're going to have to change everything. If you're going to make an 8,000 RPM motor that you're running at 8,000 RPM a lot, you're going to have to put forged everything. You're going to have to probably change the oiling system. You're going to have to do a lot of stuff. It's very, very expensive to do that. Off the wall concept here for a land speed attempt based on displacement class, building a V-twin based on a 90-degree balance shafted V6 by removing 4 cylinders and stopping the oil bleeding. There would be much better ways than doing that. I don't know which 4-cylinder or which 90-degree V6 you're talking about doing, but the way to do it is a small motorcycle engine. because motorcycle engine's going to be small displacement, and it's going to rev to between 13 and 19,000 RPM, and it will make way more power than any sort of V-twin is going to do. I run a real G35 on a 2.4 and full spool, 40 PSI by 3600. So I'm guessing you're running a lot less boost on more displacement, but the next gen turbos are much better for sure. What oil pans needed to put an LS in a 72A body like a Chevelle? Holly should have those. I was surprised 799s didn't make more power. I was actually surprised a little bit about that too. I thought that particular set of 799 heads would make more power than that particular set of 706 heads, because those 706 heads are terrible. But that's why we test. Richard, have you ever run a cam motion low lash solid roller? No, I don't run a lot of solid roller stuff because the marketplace doesn't run solid roller stuff either. They may sell one or two for every 100,000 hydraulic roller cams that they sell. So it's just not really, there's not very many people out there that would run it. Will the red out cam be okay to add boost to? Yeah. Richard, I have a 2017 Silverado with an L83 stage 4 cam. I want to upgrade intake manifold. Would you do the LT2 intake or an L86? I need to go back and look and see. I like the longer runner stuff because it makes more power in the RPM range where I would be most of the time. If you're racing this thing, I wouldn't think you'd be racing a 2017 Silverado. I would like the longer runner stuff. I haven't seen the data on an LT2 cam yet. Where do you run into piston valve clearance on a pushrod 5-liter, a 230 at 50? I don't know. 230 is usually where on stock piston to valve stuff is kind of where you start getting into trouble. You might get into it before that if you're not using a stock valve size, because the valve relief might not accommodate a 194, a 202 valve, whatever. You have to test it. Have you done an 8-into-1 versus tri-wide? I've never run an 8-into-1 on the engine dyno. So whatever cam does NA, it will do the same, but more under boost. I agree with Burns on the Turbo Sentra on your 38 millimeter. I think it'll work, but I would always go oversized on the wastegate. You'll just have better control, especially if your wastegate mounting position is not optimum. The more optimum the mounting position, the better off the control is going to be from that size wastegate. And quite honestly, what will happen if you have an undersized wastegate is you probably will have a rising boost curve, which a lot of times isn't a bad thing. Problem with motorcycle engines that are attached to motorcycles. And it is problematic, Sean, to not that. I wouldn't ride the motorcycle at Bonneville. That doesn't sound like any kind of fun to me. But it's not that. It's attaching the motor to a transmission in a car to getting it to run, because you're looking at now all of a sudden you have lots and lots of RPM. So you have to get the gearing right. So you have to get the transmission and the tire size and all of that stuff to work out. That's a little more problematic, but they do make amazing power for the displacement, obviously. Would a 406 small block Chevy with Project X 215? I don't know what Project X 215 heads are that produce the same horsepower. I don't know. You could get a 406 small block Chevy with boost to make 650 horsepower without any problem at all. You could get a 5.3 to do that. Is there a difference in LS power and small block Chevy power? I don't know what you mean. If they both make 400, they both make the same power. But you can make power with both motors. But it is easier to make more power. If you were to go to the wrecking yard, you couldn't go get a small block Chevy that makes as much as a wrecking yard LS motor. VS sells a 44 millimeter for $100. That's pretty inexpensive. Yeah, Sean, I agree. A liter bike powered Kai car would be really cool. BS show on the 4-liter Rover, Buick V8 building for max torque off idle. Yeah, again, you're not at wide open throttle off idle. So that's not really a concern. But boost is the way to do it. An M90 on that would be good. An M112, depending on how much power you want to make. We know an M90 can support. Are you talking about making more than 500 horsepower? You know, the M90 is going to be a lot less money than a 112. An intercooler would be really nice. So if you can get the M112 and package it with the intercooler, it's a little problematic the way that they have it routed because you don't have the factory intake manifold. But it's doable. But with that, you shouldn't be the tri-Y and the 4-into-1 thing you're worried about is a little thing compared to the other things that are going to help you make power. First step for me is managing to register a Kai class car. Yeah. When you recommend Inconel valves on LS boosted turbo, probably I should have used those on a number of applications already, but I haven't. I get away with a lot of stuff on the engine dyno because I only make usually a few runs at really, really high power. But in any of this 1,000 horsepower, 1,500 horsepower stuff, if you're going to get it to last a long time, or you're going to be at wide open throttle for extended periods of time, like for boat applications, I definitely would recommend it. A guy that's silly enough to run wide open throttle for the Silver State, definitely a good idea. We never, Brett, we never upgraded any of the valves on the junkyard stuff. Evan, the stock internals will work for a long time at track events. Put ring gap in it, and then but make sure that you have proper oiling. That is going to be your problem on a road race track. Is that if you don't have a good pan, a dry sump, an AccuSump, some form of better oiling than the factory has, you're going to run into problems. And it's going to have nothing to do with the strength of the pistons or the connecting rods or the crank. We already know those will go to 1,500 RPM or 1,500 RPM. We know 1,500 horsepower. So they're actually fairly strong. What the problems you're going to have are with tuning and oiling when you go to a road race track. We couldn't break the LS2 doing 72-hour track simulations on the dyno. LS3 would always break, but not the LS2. Oh, cool. I wonder why would the LS3 break? What problem did they have? What did they break? Did they break a valve? Rover motor 4-liter off idle full throttle, yes. On ramp acceleration. So you're going from on an on ramp acceleration, you're going from the dig, you're going from a dead stop to get on the freeway. So like idle is 600 RPM. So you're stabbing the throttle at 600 RPM. I'm not being facetious. I'm just saying that a lot of what people ask for, especially when I show them dyno results, is not realistic in the real world. I drive my truck and I'm never power braking it at 600 RPM to get onto the freeway. LS factory valves are pretty good. If you don't need bigger ones, then reuse them. Certainly better than the Chinese valves. I feel like Inconel isn't needed unless you're really making a lot of boost and heat. For instance, 20 PSI, no intercooler on any gasoline and fuel. Or fuel without good cooling effects. Actually, you'd be more inclined to be needing Inconel exhaust valves if you're running pump gas and taking timing out of it. The exhaust valves can get really hot. But sustained running on the exhaust, when you see the exhaust manifolds glowing red hot, the exhaust valves are taking abuse. The L3s would always jerk a wrist pin out of the piston. AccuSump it is. Yeah, they have saved us before, especially if there's any banking, Evan. We, like they have it when we race it, PIR and even here in Fontucky, what is it? The California Speedway. My old Saturn Sky had sodium-filled Inconel valves from the factory, which I thought was interesting. Tells you what they're concerned, that they are concerned with stuff like that. I didn't know much about them. We run aftermarket pistons rods in iron blocks. So we're going to end our poll at 64%, thinking that the 799 heads would make more power. And we got 2 more minutes. I got stuff to do. Got to figure out what my next video is. I think I have, though. Kazi says aluminum rods cushion the rapid acceleration of the piston. Is it the rapid acceleration away from TDC that he's talking about? Is it because the aluminum rods are stretchy? Rover, full stop to on-ramp. So, okay, not idle. Let's just say 1500 to 4500 and high 5th gear pulls. Boost is going to be the answer down there. 1400 is not going to get you. You're not going to get very much at 1400 other than boost. Headers are, I don't think, are going to do a lot there. Maybe long tube headers will. I don't know. You'd have to have them fairly long, I think, for 1400. I don't ever remember loading anything down that low to see if it happened. Even on a chassis dyno, I don't remember going that low. Tune would have to be spot on there, not detonate. Displacement. Dual superchargers, that's already planned. Richard, do you know of any remarkable configurations used for Pikes Peak hill climb? No, other than the dual motors and stuff, those kinds of things that you see, like the Suzuki one, and those are really cool. Tom, yes, I can give you a call. Quick changes in direction on mountain motors that have piston speeds faster than, they would be a lot higher than F1, right? Because of a 900-inch motor. What's the stroke on that thing? Jose, show some engine builds you've done as videos. Are you talking about my stuff? I do all the work on my on the motors that I test. There's nobody else doing it. This thing for Pikes Peak is probably electric. Air pressure doesn't matter to EV. Next gen 7875 after tuning a truck. You're a big fan of those. I have a Gen 2 one, which I like. I do perform all my own stunt work. It's funny, I get comments like that, mostly on videos that I use old photos and stuff for, because a lot of that stuff was done before YouTube. I mean, certainly before I did YouTube, and before a lot of people did YouTube, before video was a thing, at least for me, because they were all shot for magazine stories. So, and then back then, when I was shooting something for a story, they never wanted you to have, as a journalist, you weren't the story. So they didn't want you in there doing it. And then after a while, I just I'm going to do this anyway because people like this. And it turned out that they did. And it turned out that's the direction that the whole world was going. But it's still me doing all the dyno testing, me swapping all the heads. I mean, occasionally when I was there at West Tech, I would have maybe a guy-ish or Brule or somebody helping me do the test sometimes. Usually it's me, though. Usually it's me putting all this stuff together. But it's funny, I was thinking about while I was doing this last video that I put up, that I like doing all the fast motion sequences, even though it happens, it takes a lot of filming and a lot of taking all the heads off, taking the cams out, putting the rockers on, doing all this stuff. But I like the fast motion stuff because it looks like, oh, look, this guy's like super efficient. Look how quickly he can do all this stuff. It makes me look a lot better than I am. So a turbo, more plenum space could equal more lag, right? So I'm just curious, does dual superchargers will require more plenum space, so that will affect the power curve? No, I'm a firm believer that plenum volume has very little effect on power. I'd love to do it because here's what I want you to do, Keith, is what I want you to do is calculate plenum volume and then calculate the airflow of the motor. And then calculate how quickly all that plenum volume would be processed through the motor. It's percentages of a second. So the plenum volume is not like a reservoir that needs to be filled. It's not like you're having a bucket and you're filling up a big reservoir with a bucket. That's not happening. The time and the space that we're talking about here that's not a thing. It'd be much more useful and potentially power changing to talk about the resonance frequency of a change in volume, but even that is kind of a minor thing. Engine Masters did an episode on Holly Sniper 2 and noted that it's good for boost. Any plans for testing it? Maybe I'd like to use it as a blow through thing if it will work and be consistent. Yeah, Burns, one of the on the Pikes Peak hill climb, one of the best things that I read, and I forgot who wrote it, but they were talking about the race and they were talking about some of the blue sky turns. And so people that don't know what a blue sky turn is, that means where you can't see anything. And if you go off, you just launch off into blue sky because you're so high up and stuff. And they said that, yeah, some of them are so high that your clothes go out of style before your car lands. So that's how high they are. I thought, wow, that's really good writing. I like that. Do you think it would be worse stroking a 289 Ford block? A bigger is better if you want to make more power. Getting ready to replace my aluminum chopper copper cam 5.3 for an LS3. Would you swap that cam over to the LS3? Would it be worth it? That cam will work fine in an LS3. It's just going to be a little bit milder on the 6.2 than it was on the 5.3. but it'll still work. It'll still be responsive, and it'll be a good driver cam. Forum answer, plenum volume, 1.5 times a runner, 1.5 times a runner volume, or 1.5 times the displacement of the motor. Plenum volume versus runner volume would be I would be interested to see how people get that calculation and why they think that works. I've done blue sky turns, but at slow speed in a Taurus. And now a lot of Pikes Peak is actually paved, right? It used to be a lot of dirt. Where's hell? I drove around my Mustang for years and years and years. I caged it because it was a showroom stock car. It was my foray into road racing. Got my license in that car and went showroom stock racing. I bought the car specifically for that and had a cage in. Was originally an auto power cage that we then welded in place. And so I drove everywhere with that. It did have a removable and or swing out door bar. But otherwise it was a cage all the time. And so it is dangerous to do that without a helmet on. Our single cylinder Formula SAE engine was absolutely neutered without a plenum of at least 1,000 cc's. So you guys did plenum testing on your single cylinder deal? Pretty much paved to this point. Toward the top, there's a few spots where dirt and rocks get on the road. Yeah, we did put James. We put padding on we had padding on the cage, and that's mandatory for our SCCA rules. Have you ever scared your significant other? Yes, but not by trying to show off. Just more the when you race, especially when you road race, your comfort bubble is a lot smaller than other people's that are on the road, unless they also happen to be, road racers. My comfort bubble, I keep telling people, is actually a little bit inside the paint. So I'm not afraid to trade. So, when you get close to people, I'm like, I'm not worried about that. I got this. Even if it clicked mirrors or whatever, it's not a big deal. It's much better to not worry about that than it is to freak out and make a big crazy move. I'm like, look, even if they hit me a little bit, it's not the end of the world. I'll keep going. I've done it many times in races, rubbing's racing. That's part of the deal. So having that sort of mentality when you're out driving for a lot of people is, some people don't even want to drive, like they don't even want to pass a big rig. How many times have you been on the freeway where it's a 2-lane freeway going this way and a 2-lane freeway going that way, and you're driving up next to the other one, and the other person won't pass the truck until the other person that's in front of them is way up ahead, so they can go wah and go like right past. I'm like, you're putting yourself in danger by doing something dumb because you're afraid that somehow a big rig truck is magically going to transport itself over into your lane before you could either accelerate or move over or brake or otherwise avoid whatever thing you would have happen. Don't freak yourself out because you're driving next to a big truck or whatever. It's just silly. As general rule, the more cylinders the plenum feeds, the less the plenum volume matters. That's an interesting theory. I think that's true. I think on a single cylinder that might be more susceptible. I would like to see testing on that. Helped a ton, so we tested to see how big and small it needed to be for maximum effort. And when you on Grooves and Land, were you guys doing this for like maximum acceleration. Like it wasn't just a specific power at a specific RPM thing, right? It was like you were using it as a performance thing, right? What power would the M90 make on 93? Well, given the fact that we're only running like 8 or 9 pounds, we probably could get all the timing that we're running on E85 on 93, especially because we're running this motor cold and we have cold air going into the motor. If you're running an intercooler, you could definitely get all of the timing on 93. You're just not going to get the added power from the E85. ITPs on an NA generally pick up power. Burns, that's because they have infinite plenum volume. so the resonating frequency is infinite. We need V12s to test the plenum theory. Well, we could do that on the V10 Ford, right? Yeah, it was maximum performance of the little open wheel car. So you're trying to make like some sort of average power thing, which is kind of cool. Without a full plenum, the restrictor would permit the airflow in that short time. And then you think that you would have refilling of the cylinder, or do you think that the plenum volume is a cylinder filling resonance frequency? See, that's what I would lean toward. I would need to see what the power output is and the airflow is, and then the volume, because when you see what the volume is versus the airflow, it evacuates what would be a complete volume in very, very little time. Are you going to test the V10? I don't know. Yeah, I want to. I was thinking about putting it in my Mustang. I think the cylinder drew from the plenum during the intake stroke, then the plenum refilled during the other 550 degrees of crank rotation. That's a good theory. We could do the math on that and figure that out if that's happening. I could tell you that plenum volume definitely has a change in resonating frequency. And if you can match that resonating frequency and it's be cool on a single cylinder, it'd be much less problematic on a single cylinder because you don't have a bunch of other counter reflected waves that are possibly offsetting what is essentially a minor resonating frequency wave, but does help cylinder filling. So if you could have that happen on a single cylinder and you don't have other things that are stopping it from doing that, that's kind of cool. Makes a colossal difference in power. That's awesome. And I'm thinking that that's not airflow. I think that's also something else. But I'd like to. I now want to calculate that and find out what the airflow is, because we could calculate it based off power. Before adding the plenum, our whole powertrain concept was a total failure. And then you have to, when you do that, you should also did you guys then attack the exhaust side too to see if there was something there? When are we going to argue about whether it's all Teslas? Yeah, it's not all Teslas. But on that note, it is time to go. But I will be back tonight. And if you have not, please go take a look at the video that I put up. Inch and 3/4 versus inch and 7/8 headers, 706 versus 799 heads, and camshaft versus camshaft. What more could you want? It's all good. And on that note, I will see you guys all tonight. I got to go get Bruno and Brady and Milo.